Hello everyone. In this video we will learn about the solutions of the problems given in the exercise 7.2 of NCERT for class 12th. That is based on integration by substitution. We have already learnt about the method of substitution, that is that in case any function of x is given to us and its derivative is given in the multiplication, then we can consider that particular function fx as t. That is known as the substitution. We have also to remember one thing, that our solutions must be self-explanatory. What is the meaning of self-explanatory? It means anyone who is going through the solutions given by us or given by you should be able to understand what we have written and what we want to say. So here we are coming to question number 1 of the exercise, that is integral of 2x upon 1 plus x square. In such problem we can remember one more rule, that if f dash x upon fx dx is asked for the integration, then the integral of that is log of fx plus c, and here we have to use the modulus sign because log or logarithm of any of the function is for the positive values. So here in this particular problem what we are getting is 1 plus x square is the function which we can consider as fx. So if we take fx is equal to 1 plus x square, we are getting f dash x is 2x, which is available here. So we can write this as f dash x upon fx, and then the answer comes as log of fx plus c, or we can say log of 1 plus x square plus c. So this is one of the method we can use to find the solution if we apply this particular formula. Now in case you don't want to use that, then like in this particular question we can consider any of the function which is given for x as t. If we consider this log x as t here, we know that the derivative of log x is 1 upon x, which is available here in multiplication. So we can write here, let log x is equal to t, and if log x is t, differentiating this we get 1 upon x dx is equal to dt. It means this 1 upon x into dx will come as dt. This is t, so the function becomes t square dt. And we know that integral of x power n is equal to x power n plus 1 upon n plus 1 plus c. So here we get here, this is t cube upon 3 plus c. Substituting the value of t, we get here log of x whole cube upon 3 plus c, which is the answer to this particular problem. Here third question is integral of 1 upon x plus x log x. What we do here, we can take x common in the denominator and we get here 1 plus log x. Now we know the derivative of 1 plus log x is 1 upon x. So either we can substitute t for 1 plus log x, or we can consider this as fx. Suppose we consider this as fx, let fx be 1 plus log x. In that case, the derivative of this, that is f dash x, will be 1 upon x, and hence we can write this as f dash x upon fx. And we know the integral of f dash x upon fx is equal to log of fx plus c. So here also we can do the same thing. We can write this as log of fx plus c. Substitute the value of fx, we get here log of 1 plus log x plus c. This is the answer to the problem. Now in the next question, question number 4, we are getting this is integral of sin x into sin of cos x dx. We know that derivative of cos x is minus sin x, which is available here. So we can consider cos x as t. So we can write here, let cos x is equal to t. Differentiating this, we are getting minus sin x dx is equal to dt. So we are getting here minus, this is sin t, and this sin x into dx becomes dt, minus we have already taken here into dt. And we know the integral of sin t is minus cos t. So this becomes minus of minus cos t plus c. Substituting the value of t, we get here plus cos of t means cos x plus c. This is the answer to this particular problem. The fifth question here is integral of sin ax plus b into cos of ax plus b. This particular problem can be solved in three different methods. The first method we can find by taking this particular one as t. Why? Because we know derivative of sin ax plus b is cos of ax plus b into a. Once it is here, we can take this as t. So we write here, let sin of ax plus b equal to t. Differentiating this with respect to x, we get cos of ax plus b into a dx is equal to dt, that is by applying the chain rule. This gives us cos of ax plus b dx is equal to dt upon a. It means this particular one can be written as 1 upon a t dt, and we know the integral of t is t square by 2, so this will be 1 upon a into t square by 2 plus c. Substituting the value of t, we are getting 1 upon 2a into sine square ax plus b plus c, because t is sine ax plus b. And this is the answer to the problem. The second method can be applied here, taking this as t, because we know derivative of cos x is minus sin x. So if we take here cos of ax plus b equal to t, differentiating this, we are getting minus sin of ax plus b into a dx is equal to dt, applying the chain rule. And hence we get here sin of ax plus b dx is equal to minus dt by a. So this becomes, this we can write as I, the integrand. Therefore I can be written as minus 1 upon a t into dt. Integral of t is t square by 2, so this becomes minus 1 upon a into t square by 2 plus c. Substituting the value of t, we get here minus 1 upon 2a into cos square ax plus b plus c. This is the answer. The third method we can apply here, taking the formula sin 2 theta is 2 sin theta into cos theta, from which we get sin theta into cos theta is equal to sin 2 theta by 2. Applying this, can we write this I as integral of sin of 2ax plus b upon 2? And here we can take 2 into ax plus b as t. So we write let 2 into ax plus b equal to t. Differentiating this with respect to x, we get 2 into a dx is equal to dt, or we can say dx is equal to dt upon 2a. Here we know that derivative of x is 1 and that of b is 0. So we get here 1 upon 2 into 1 upon 2a sin t dt. We know the integral of sin t is minus cos t. So we can write it as minus 1 upon 4a into cos of t plus c. Substituting the value of t, we get minus 1 upon 4a into cos of 2ax plus b plus c. This is the answer to this problem. We find here by applying these three different methods, the answers are in the different forms. But if we apply the trigonometrical formula here, we will find the answer to this all three same. So we have to remember here one thing, that in case we are applying the different methods for any of the substitution, the answer may be in different form. But that will be correct if our procedure is correct, the algorithm is correct, and the formulae applied are correct. Sixth question is integral of root ax plus b. When there is a radical power, like it is square root, which is half power of ax plus b, then what we do, we consider this either as t, or to avoid the radical powers, we can also take it as the power of t equal to the denominator of the power of fx. Here this particular question we can do in two different methods, which I have told just now. The first method we can take here is, suppose we take ax plus b as t. Then differentiating this, we will be getting a into 1 plus this is 0, so this will be a into dx is equal to dt, or we can say dx is equal to dt upon a. And hence this particular question will become 1 upon a into root of t dt. Then we know this is t power half. We can write this as 1 upon a integral of t power half dt. And we know the integral of x power n dx is x power n plus 1 upon n plus 1 plus c. If we apply that here, we will be getting 1 upon a t power 3 by 2 upon 3 by 2 plus c. We can also write this as 2 upon 3a into, substituting the value of t, that is ax plus b power 3 by 2 plus c, which is the answer to the problem. In the second method, when we want to integrate root of ax plus b, then we know that this is ax plus b whole power 1 by 2, square root of ax plus b. It means the denominator of the power is 2, and hence we can consider ax plus b as t square. Differentiating this, we will be getting a into dx is equal to 2t dt, or we can say dx is equal to 2 upon a into t into dt. Substituting this here, we will be getting 2 upon a into, this is t and this is t dt. So this becomes now 2 upon a into integral of t square. And we know integral of t square, according to this, will be t cube upon 3. So this is 2 upon a 1 upon 3 into t cube plus c. Substituting the value of t, we are getting 2 upon 3a into t is root of ax plus b, or we can say ax plus b power half, cube of that will be ax plus b whole power 3 by 2 plus c. Same answer we are getting by this method. But the only difference here is that we are avoiding the radical power of t here. Question number 7 is integral of x into root of x plus 2 dx. In this also, if we want to avoid the radical power, we can consider x plus 2 as t square. Differentiating this, we are getting dx is equal to 2t dt, but we have here x. The value of x from this we are getting is t square minus 2. So in this case, we will write here t square minus 2 in place of x, t in place of x plus 2, and this is 2t dt. This is 2 into t, that is 2t square. If we multiply inside, we are getting 2t to the power 4 minus 2 into 2, 4t square dt. And now, according to this particular rule, x power n, we will be getting the integral of this as 2 into t to the power 5 upon 5 minus 4 into t cube upon 3 plus c. Taking 2t cube common here and 15 as the LCM, we are getting here 3t square minus 4 into 5 divided by 2, that will be 10 plus c. And now we substitute the value of t. T is x plus 2 power half. Q will be x plus 2 power 3 by 2 into t square is x plus 2. So this is 3 into x plus 2 minus 10 plus c. If we simplify this, we are getting 2 upon 15 x plus 2 power 3 by 2 into 3x minus 4 plus c, which is the answer to this particular problem. Eighth question is integral of x into root of 1 plus 2x square. We know that d by dx of x square is 2x. X is available here. So we can consider this function as t, or to avoid the radical power as t square. Suppose we consider it as t square. Differentiating this, we will be getting here, differentiating with respect to x, we are getting 4x dx is equal to 2t dt. Or we can write x dx is equal to 1 upon 2 t dt. So here if we take 1 upon 2 out, this 1 plus 2x square, root of this will be t. X into dx is t dt. So this becomes half into integral of t square. And we know the integral of t square is t cube by 3. So this will be 1 upon 2 into t cube by 3 plus c. We can write this as 1 upon 6. T is root of 1 plus 2x square, that is 1 plus 2x square by half. Cube means this can be written as 1 plus 2x square whole power 3 by 2 plus c, which is the answer to the problem. Question number 9. We have integral of 4x plus 2 into root of x square plus x plus 1. If we consider here x square plus x plus 1 as t square, differentiating this, we are getting 2x plus 1 dx is equal to 2t dt. What we see here is, if we take 2 common from this becomes 2x plus 1 into root of x square plus x plus 1. And hence, if we substitute this here, we are getting 2 into, that is 2, this will be t dt and this is t. So t into t dt. This comes as 4 into integral of t square dt. And we know the integral of this is t cube by 3. So this will be 4 by 3 into t cube plus c. Substituting the value of t here, we get 4 by 3. T means x square plus x plus 1 power half. Cube of that will give us 3 by 2 plus c. This is the answer to the problem. 10th question is integral of 1 upon x minus root x. If we take root x common in this, we will be getting this as 1 upon root x into root x minus 1. And now we can take root x minus 1 as t. If we take root x minus 1 as t, differentiating this, we will be getting 1 upon 2 root x dx is equal to dt. We already have here 1 upon root x. So we can write here 1 upon root x dx is equal to 2 dt. This 2 we can write here, and this is 1 upon, this is t, and this comes in as dt. and we know the integral of 1 upon t is log t, so this becomes 2 log of t plus c. Substituting the value of t here, we get 2 log of t means root of x minus 1 plus c. This is the answer. 11th question is integral of x upon root of x plus 4 dx. Here we can consider x plus 4 as t, or to avoid the radical power as t square. So we write here, let x plus 4 equal to t square. Differentiating this, we will be getting dx is equal to 2t dt. But here we have x. So we can find the value of x from here in terms of t, that is t square minus 4, because we have to make this complete function as of t. So we write here, this is t square minus 4. Root x plus 4 is t, and dx is 2t dt. This t and t cancel. 2 in multiplication, and here we have t square minus 4 dt. If we integrate them separately, we are getting 2 into, this is t cube by 3, minus this is 4 into t plus c. If we take t common and 3 is the LCM, will we be getting here 2 upon 3 t into, this will be t square, minus this will be 12 plus c. We can substitute the value of t and t square, so this will be 2 by 3. T is root of x plus 4. Inside this, it will be x plus 4 minus 12 plus c. If we simplify this, we are getting 2 by 3 root of x plus 4 into x minus 8 plus c. This is the answer to this problem. 12th problem here is integral of x cube minus 1 whole power 1 upon 3 into x power 5 dx. We can consider x cube minus 1 as t, or to avoid the radical power as t cube, because the denominator in this power is 3. Suppose we consider x cube minus 1 as t cube. Differentiating both the sides, we are getting 3x square dx is equal to 3t square dt. This 3 and 3 cancel. So we are getting x square dx is equal to t square dt. But here we have x power 5. Can we write this as x cube minus 1 whole power 1 upon 3 into x cube into x square? Why? Because we have got the value of x square dx from here, and x cube we can find from here, that will be x cube is equal to t cube plus 1, because we have to convert this particular function in terms of t. So substituting the values, we are getting here x cube minus 1 power 1 upon 3 will be t. X cube, that will be t cube plus 1. Into x square dx will be t square into dt. Simplifying this, we get t into t square is t cube into 2 cube is t power 6, plus t cube into 1 is t cube into dt. We know integral of x power n is x power n plus 1 upon n plus 1 plus c. Applying that here, we get this as t power 7 upon 7, plus this will be t to the power 4 upon 4 plus c. We can take t to the power 4 common here and 28 as the LCM. So we will be getting here 4 into t cube, plus this will be 7 plus c. Substituting the value of t here, we get t means x cube minus 1 whole power 1 upon 3 whole power 4 will be 4 by 3 upon 28 into 4 into t cube is x cube minus 1 plus 7 plus c. Simplifying this, we are getting x cube minus 1 whole power 4 upon 3 upon 28 into, this will be 4x cube minus 4 plus 7, that is plus 3, plus c. This is the answer to the problem. The remaining problems of the exercise we will be discussing in the next videos. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.